Okay, first we're going to look a little bit at kind of what exactly is a bond. What are we talking about when we mean a bond? Just so you'll have a little insight into what it is that we're trying to model with the Lewis structures that we'll be drawing. And so we're going to look at a couple of things here. But the first thing is to realize that in this model that we're looking at, we create a bond by sharing pairs of electrons. And we're going to see some pictures to kind of give you an idea of what that means. But we're going to be using two different types of models, and a good way to think of it is that the Lewis structures are kind of our two-dimensional model. This is just where we're going to be able to see the arrangement of the atoms and the electrons in the molecule. Whereas the VSEPR model is where we're going to look at the Lewis structure to determine what the three-dimensional shape of the molecule is. Okay? In looking at in detail at the bonds within the molecule, that's a little bit beyond the honors chemistry class, and so I'm just going to kind of mention it and show you some pictures, but we're really not going to get heavily into that. So basically, these the models that we look at basically describe a bond as an overlap of atomic orbitals. And so what that does is it creates an area where we have a lot of electrons, and this area is, as shown here, in between the two atoms in this particular hydrogen molecule. And so remember when we talked initially about bonding, we said, okay, it's always something positive attracted to something negative. And so in here, this type of a bond, we have our positive nucleus, which I really need a different color to draw on this red. Okay, so we have our positive nuclei in here, and then this region in between where the orbitals overlap, we get a high density of electrons. The electrons are spending a lot of time in between the two nuclei, so we have positive nuclei attracted to the negative electrons. And so that is what makes our bond. Okay, and again, looking at it from in use of some terms that we've dealt with before, here we have hydrogen, and it's got its valence electrons. Remember, this bonding occurs with our valence electrons. So its valence electrons are in the 1s, okay? And here we're bonding it to a sulfur atom, and sulfur has got valence electrons in the 3p, and so you see it's got two of the 3p orbitals have one electron each in them, and so what's going to happen is it's going to overlap. The hydrogen is able to overlap the orbitals, these two orbitals here, to form our molecule. Okay, and so that's what we mean by orbital overlap. That's our model of a covalent bond. Okay, so drawing Lewis structures. You have a handout that has a more detailed step-by-step procedure. This one that's shown here is very broad, but this is the basic procedure that I'm going to use in drawing these, and that you should use. Go through the same procedure in this order and draw very easy. Okay, the first step in this, the first thing we need to do is to determine how many total valence electrons we have to use for our model. And so we're going to look at the compound. Here we have nitrogen trifluorides. I have one nitrogen and I have 3 fluorines. To find the number of valence electrons, you're going to go to the row that the element is in. Starting at the left, you're going to count all the S and P block electrons that you go through to get to that element. So for nitrogen, we have 2 S's and 3 P's, so a total of 5 valence electrons from the nitrogen. And then for fluorine, I have 2 S's and 5 P's, so 7 electrons for the fluorine. So 5 and 21, so that gives me 26 valence electrons to work with. Okay, that's how many I have available. Now, we're going to draw the skeleton structure, and in determining which one you're going to put in the middle. In Lewis structures, typically you're going to have one central atom, and then you're going to put all the others around it. And so to decide which one goes in the middle, you're going to look for the one that has the lowest electronegativity. Okay, that's the one that's going to go in the middle. An exception could be hydrogen. Hydrogen can never go in the middle because it can only bond to one other thing. So we're going to take and do our skeleton structure, which would just be, by that I just mean we're going to lay it out by itself. So this would be before we actually put in any bonds. Then we're going to bond each outer atom to the center with a pair. Now, in Lewis structures, we're working with pairs of electrons. Okay, so we're going to attach those, and then we're going to go around the outer atoms to make up our octets. The octet rule says everything wants 8 valence electrons, except for hydrogen. Hydrogen only wants 2. So we have used 6 in our bonds: 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, then 26. Once I get to that number, I have to stop. That's all the electrons I can use. Can't use any more. And in this case, if I go back and look, yes, I have 8 on everything, and I'll only use 26 electrons. So that is my Lewis structure. Now, you'll see on the PowerPoint slide here, for the bonding pairs, they used lines. And that's fine to do. You can represent bonding pairs with a line if you want to. Just remember as you're doing that each line represents 2 electrons. Alright, so let's take a look at another one then. Here's CO2. So I have a carbon, oxygen. I have 1 carbon and 2 oxygens. Okay, I have 4 valence electrons from the carbon, 6 from each oxygen. So that's going to give me a total of 16. Lay out my structure. Also, another good rule of thumb is if carbon is in the compound, it's always going to go in the middle. Okay, so save you from having to look for electronegativities here. We're going to bond the oxygens to the carbon, each with a pair. So 4, there's 6, 8, 10, 12, 14, 16. I have to stop now, run out of electrons. Now, what happens here? I have used up all my electrons, but the carbon does not have a full octet. Well, alright, let's introduce a little terminology. These guys right here, pairs not involved in a bond, these are called lone pairs. Okay, and these are called bonding pairs. Okay, a bonding pair is shared by 2 atoms. A lone pair is only attached to 1 atom. So what I need to do is I need to take one of these lone pairs, and I'm going to move it from being a lone pair into being a bonding pair, so that now the carbon can take credit for it, and so can the oxygen. I'm going to do the same thing on the other side. I'll move one of these in. Okay, so now I've only used 16 electrons, but everything has 8 around it. This is called a double bond.